So we'll get practice question set number 9. Question number 1 says Newton's law of universal gravitation has a mathematical relationship similar to the one developed by who? Yep. C. No. Lenz? No. A. Coulomb. Coulomb's law, right? It's the inverse square relationship. KQ1, Q2 over R squared, GM1, M2 over R squared. Yeah, you haven't learned about Lenz. In fact, you haven't learned about any of these guys yet. You haven't learned about Einstein. We will later on. We haven't learned about Lenz, although we will later on. You haven't learned about Ohm. We won't learn about Ohm at all in Physics 30. If you don't recognize the name, if you haven't been taught about the name, it's not the answer. Yeah.
Don't we use Einstein's law of
No. Einstein's energy mass equivalence, that comes about later on. We said energy is conserved. Sometimes we said energy is conserved. We said momentum is conserved. That's not an Einstein thing. Okay, that's a classical physics thing.
Oh, no, I meant the every force is equal, not just reaction.
Yeah, that's not Einstein. That's Newton.
Oh, yeah.
Yeah. 2. Which of the following graphs represents the relationship that Coulomb determined between the force and the distance between two charged metal spheres? Force and distance is which one? D. Yeah, force and distance is D. Now, if I wanted to change this to make C the correct answer, how would I change it to make C the correct answer? There's 2 ways that I can think of to make C the correct answer. David, what's one of them? Yeah, if I plotted F versus 1 over R squared, that would give me a straight line. What's the other way to make C the correct answer? Emma? Yes. So instead of plotting F versus R, you would plot F versus Q1, or F versus Q2 would give me a straight line in both cases. Good? Number 3, the magnitude of the electric force on an alpha particle that's this far away from an electron. This is just a straightforward question, if we know the charges, that is. The charge of the electron, the alpha particle is 2 times the elementary charge, which is 2 times 1.60 times 10 to the minus 19 coulombs. We're going to say the charge of the alpha particle is 3.20 times 10 to the minus 19 coulombs. And we're going to say the charge of the electron, that's 1 times the elementary charge. So it's just going to be 1.60 times 10 to the minus 19. Shouldn't it be negative? Well, it is negative, but we always drop the sign of the charge when we sub them into an equation. So we're just going to say positive 3.2, positive 1.6. Gives us an answer. I believe it was D, isn't it? You guys get D? Yeah, good. And 4, finally. This takes us way back to our last unit, in a sense. We learned last unit how to change the value of variables without knowing what the variables were to begin with. We called it variable value changing. It's exactly what this is. We can see that applied anywhere in Physics 30. Anytime we have an equation, this technique can be used. We're saying that we have a certain force. We change one thing, the separation distance, R. We change it to 2/3 R. What's the force between the spheres? What's the force between the spheres going to become? Well, this is my original force. My original force is KQ1, Q2 over R squared. Now, this is before I make any changes to it. My new force, after I make my changes, is KQ1. There's no changes to K and Q1 and Q2, right? So we're going to leave that as is. But my new distance is not R. My new distance is 2/3 R. But be careful here. You're not squaring R. Nowhere are you squaring R. Not even the first one. You're not squaring R. You're squaring the distance. You're simply representing the distance by R. We're still squaring the distance, but my distance is now not R. It's 2/3 R. So we're not squaring. We're not saying 2/3 times R squared. We're saying 2/3 R squared. Does that make sense? We're squaring the whole thing because the distance is 2/3 R. Now, let's simplify this a little bit. Try to make it look a little bit more like one of these answers here. Let's say KQ1, Q2 over, that would be 4/9 R squared. Once we pull it out outside of the brackets. And then once we divide by a fraction, same as multiplying by a reciprocal, we get 9 over 4 times KQ1, Q2 over R squared. And 1 over 4 over 9, same as 9 over 4 times KQ1, Q2 over R squared. Now, we know what the value of this is. Well, not the value of it, but we know that it's my original force. So I'm going to say that my new force is 9 over 4 times my original force. How many people said D for that one? How many people said C for that one? A couple of people? Yeah, I expected people to say C, right? Because people forget to, or don't think to square that. Okay, next time if you said that, that's fine. Next time, don't do that. If it's squared, square the whole thing.